Hello everyone, welcome back. This is Professor Xiao. This video will discuss the confusion matrix in precise terms and explain several model evaluation metrics with the help of the confusion matrix. This is to help you understand these metrics so that they stick in your brain and it becomes harder to forget or to make mistakes. Here is the confusion matrix based on a binary classification framework. This video will assume that you understand these four basic terms. These are the four cells of the confusion matrix. Now keep in mind that the way the confusion matrix arranges these four cells make a big difference in the way that you interpret the results. The way I recommend and I follow throughout the course and the lecture, as well as in these videos, is that I arrange the predictions on the top as two columns and the actual labels on the side as two rows. The label 1, which refers to the positive outcome or positive label, is the first column in the two columns of predictions and is the top row of the two rows of the actual labels. A fundamental understanding of the confusion matrix for this layout is that the two cells on the diagonal line, which is this line, refers to the two true outcomes, true positive and true negative. In the contrary, the two cells on the off diagonal line, which is this line, refers to the two false outcomes, the false negative and the false positive. Whereas true positive and true negative are straightforward to understand. They are the truthful or correct classifications of the positive label and the negative label. However, the two falseful outcomes are less intuitive. Whereas the false negative has the negative in its name, it's actually referring to a positive outcome incorrectly classified as the negative. As for the false positive term, it's actually referring to a negative case, incorrectly classified as a positive label. You will also notice that the names of these terms are mostly referring to the prediction labels. Thus, the two positive label, whether or not true positive or false positive, are under the column of the predicted positive, whereas the two negative labels, false negative and true negative, are under the column of the negative label. So keep these in mind. I will refer to these terms and I will refer to the columns and the rows when I talk about the different model evaluation metrics. I will focus on these evaluation metrics. Here are the formula. For each of these evaluation metrics, I will talk about an intuitive way to understand each of these by making use of the confusion matrix so that you don't have to remember what is the formula. To quickly understand the error rate, it is describing the two falseful classifications, false negative and false positive. Error rate is the ratio of the falseful classifications, the combination of the two off-diagonal line cells out of the total of the entire confusion matrix. You can get the total of the four cells by adding the four cells all together, which will become the denominator. To understand false negative rate, it's describing the false negatives. I mentioned that false negative is one of the two off-diagonal cells. The false negative particularly is under the negative prediction column. So it's this cell on the off-diagonal line. I also want to say that whenever you hear false negative, because it's a falsely predicted negative classification, it's actually describing the positive cases. They are actually positive labels, but incorrectly classified as having negative label. So false negative rate is the ratio between false negatives and all positive actual labels. The first row contains all the positive actual labels. So to get the denominator, you will calculate the total of the first row, and you will observe that false negative is part of the first row. So this division will make sense. So to understand false negative rate, it is describing the ratio of the false negatives out of the total of the first row, which is the total number of cases with the actual label of 1, which is a positive label. Conversely, to understand false positive rate, it's describing false positives. So it's the other cell of the off-diagonal line. And by the same logic, it is calculating the ratio between false positive and the row sum of the negatives. it's this row. To emphasize again, when you hear false positive, because it's false, it's actually describing those cases with the actual label of 0, the negative label. So to quickly understand false positive rate, it's the percentage of false positives out of all the actual negatives. The total number of actual negatives is the row sum of the bottom row in the confusion table. So the three terms that I just talked about were describing the errors. And now let's move on to the accuracies. The overall accuracy is describing the ratio of the truthful classifications, which are the two cells on the diagonal line. You will calculate the total of the diagonal line, two cells, divided by all the cases, which is the sum of all four cells of the confusion matrix. So that's pretty straightforward. Moving on. To understand true positive rate, it is describing the true positives. It uses one of the two truthful cells, which are one of the two diagonal line cells, and the true positive cell is the top one. True positive rate is the ratio of the true positives out of all the positives. Because the term is not confusing, you immediately think of the first row as the total number of positive labels. So that is this ratio. And by the way, true positive rate is also called recall and also called sensitivity. These three terms in the binary classification context are exactly the same. To understand true negative rate, it's describing the ratio of the true negatives, which is the other cell, the bottom cell of the diagonal line, two cells. It's the ratio between true negatives and total negatives. You know by now that total negatives is the row sum of the bottom row with the actual negative labels. And by the way, true negative rate is also known as specificity. The six terms that I just talked about are often discussed in data science projects with a binary classification problem. Some additional terms that are often mentioned include the positive predictive value, PPV. Be cautious that the positive predictive value, which focuses on prediction as the predictive keyword is in the name, it's not referring to the actual labels, but it's based on the predicted labels. Here's what I mean. The predictive positive value, first and foremost, focuses on the true positive predictions. So it's the top cell of the diagonal line. But instead of the ratio between this cell and the row sum, the positive predicted value is the ratio between true positive and all the positive predictions, which will be the column sum of the positive predicted labels. So positive predicted value is describing the proportion of true positives out of all the positive predictions, not necessarily all the positive actual labels. So it's focusing on the predicted labels. And by the way, PPV is also known as precision. So with all that said, another frequently used metric to evaluate models, especially in comparing models from very different binary classification problems, is an F1 score. F1 score combines two metrics that we talked about just now, the precision and the recall. And you know that precision is also known as positive predicted value, which focuses on the prediction. Recall is also known as true positive rate. It focuses on the positive actual labels. So that's why when you observe the formula again, whereas for the precision, the denominator includes true positive and false positive. So it focuses on the positive predictions. The recall formula has true positive and false negative in its denominator. False negative is positive actual labels. So it focuses more on the ground truth, the true positive outcomes. So F1 score is calculated as this big formula. But because you have calculated the PPV and TPR earlier, you will plug in the number and calculate the F1 score.